Hello guys, today we are going to see recurrence relation for the moment of binomial distribution. For the moment of binomial distribution, we have to prove that mu r plus 1 is equal to pq n r mu r minus 1 plus d mu r by dp. First, mu 1 is equal to expectation of x minus x bar is equal to x bar is nothing but mean, that is np. Mu 1 is equal to summation x is equal to 0 to n x minus np. We have to write the formula, that is binomial formula ncx p power x q power n minus x. Now we have to proceed like this for mu 2, x is equal to 0 to n x minus np whole power square ncx p power x q power n minus x. And proceeding like this, we will get mu r minus 1 is equal to summation x is equal to 0 to n x minus np whole power r minus 1 ncx p power x q power n minus x. It is nothing but we have to just change the power, and the under mu value must be written on the power. Like this, we are writing mu r and marking as equation number 1, and mu r plus 1 and marking it as equation number 2. Now we have to differentiate mu r with respect to p. So we will write d mu r divided by dp is equal to summation x is equal to 0 to n ncx we should write as it is, that is nothing but uv method. Equation 1, there is u and v. ncx we are taking it out. Now x minus np the whole power r is u p power x. For p power x q n minus x, we are applying uv method, so that u is there. For v, x power n formula n x power n minus 1, so that n minus x q n minus x minus 1, where q is equal to 1 minus p. While we are differentiating minus p, we will get minus 1, so that's why there is minus 1. Next, v u dash. V we will write as it is. If we differentiate p power x, x into p power x minus 1, that's it. Then for we have written for v, now we have to write for u, so that p power x q power n minus x we should write as it is, and we have to differentiate x minus np the whole power r, so that r will come front, r into x minus np whole power r minus 1. Now if we differentiate again, we will get minus n, so that minus n occurs there. Now for the other step, we have to add and subtract 1, so that x is equal to 0 to n ncx x minus np we should write as it is whole power r. Now here we should add and subtract 1, p power x minus 1 plus 1. Then n minus x we should write as it is, q power n minus x minus 1 as it is, then minus 1 as it is, plus we have to apply here plus 1 minus 1, then x into p power x minus 1 plus we have to get that inside, that is multiply inside. Summation x is equal to 0 to n ncx. We are getting minus n and r there, so that we are writing there as minus n r. Then x minus np whole power r minus 1 p power x q power n minus x. We have to get that minus outside. Then what we are doing is taking it as common. We are taking x minus np whole power r, p power x minus 1 and q power n minus x minus 1 as common. First we are writing the minus outside, so this step is the same step as before. In the following next step we are taking common. Summation x is equal to 0 to n ncx. Now we are taking common x minus np the whole power r, p power x minus 1, next q power n minus x minus 1, so that we will get here we have minus 1 and here we have 1p, so that minus p, then n minus x is that, so that we are writing that n minus x, next plus there is a q and then x, q and then there is the x, so that qx. Next minus nr, we are writing the whole term as in mu r minus 1. It is nothing but mu r minus 1, mu r minus 1 formula, so that we are writing just mu r minus 1. In the next step we are multiplying that minus p into n minus x. First we are multiplying minus p and minus x, so that it becomes xp, then minus np, then there is a qx, then minus n into r mu r minus 1. The next step we are writing as it is, and taking x as common. So that it becomes x into p plus q, then minus np. then minus n r mu r minus 1. P plus q is nothing but 1. Summation x is equal to 0 to n nc x minus np the whole power r x minus 1, that is nothing but 1, so that minus np whole power 1. Then we are writing p power x. Then we are taking that minus 1 to the denominator. Likewise we are writing for q power n minus x divided by q. Then minus n or mu r minus 1. For this x is equal to 0 to n nc x. This base is same, so the power will be added, r plus 1. Then p power x divided by p, q power n minus x divided by q. Then minus n or mu r minus 1. By equation 2, we can write that as mu r plus 1. Then we have denominator p and q, so that we are writing it in the denominator. Minus n r mu r minus 1. In the left hand side we have d mu r divided by dp. Now we just want mu r plus 1, so that we are keeping it as it is, then taking another to the left side. So it becomes mu r plus 1 is equal to pq into n r mu r minus 1 plus d mu r divided by dp, and we mark it as equation 3. Hence proved. Now we know that r is equal to 1, 2, 3, etc. So we put r is equal to 1 in the above equation, that is equation number 3. We get mu 1 plus 1 is equal to pq n into 1 mu 1 minus 1 plus d mu 1 divided by dp. Here mu naught is equal to 1 and mu 1 is equal to 0. So here left hand side becomes mu 2 is equal to pq into n mu naught d of 0 divided by dp. Now it becomes pq n into 1 plus 0. Then mu 2 becomes npq. We are writing for r is equal to 2, so that put mu r is equal to 2, not mu, sorry, it's r equal to 2. Then mu 2 plus 1 is equal to pq n into 2 mu 2 minus 1 plus d mu 2 divided by dp. In the left hand side it becomes mu 3 is equal to pq into 2n mu 1 plus d mu 2, we are substituting npq, so that npq divided by dp. Then it becomes pq into 2n mu 1 means 0 plus d by dp into npq. Now if we multiply with 0, it becomes 0, so that 0 plus d by dp into npq. pq we are taking n outside because it is a constant, then d by dp into pq. For q it is 1 minus p, so that we are substituting that npq into d by dp divided by dp into p into 1 minus p. We are taking the p inside, so that npq into d by dp p minus p square. So if we differentiate this with respect to p, it becomes npq 1 minus 2p. Then we are separating 2p as 1 minus p minus p. For 1 minus p, we are substituting q, because 1 minus p is equal to q, npq into q minus p. So mu 3 is equal to npq q minus p. That's all. Then proceeding like this for mu, that is r equal to 3, it becomes mu 3 plus 1 is equal to pq into n into 3 mu 3 minus 1 plus d mu 3 divided by dp. Then 3 plus 1 becomes mu 4 is equal to pq into n into 3 mu 2 plus d by dp. We are substituting for mu 3, that is npq q minus p. Then for mu 2, we are substituting in the another step, that is pq into 3n mu 2 is nothing but npq, then plus n is a constant, so that we are taking outside, then d by dp into pq into q minus p. Next step, we are writing q as 1 minus p, and in the front we are multiplying inside, just multiplying inside. Then we should write q as 1 minus p, p into 1 minus p, 1 minus p minus p. Okay, next, in the next step we are writing 3n squared pq plus n d by dp. We are multiplying inside. First we write minus p as minus 2p. For that step alone, I have written here 1 minus p into 1 minus 2p. We are multiplying p first, p minus p square, then 1 minus 2p. We are multiplying again, it becomes p minus 2p square minus p square plus 2p cube, so that it becomes minus 2p square minus p square becomes minus 3p square plus 2p cube. We are substituting there, is equal to pq into 3n square pq plus n divided by d by n into d by dp into p minus 3p square plus 2p cube. Next, we are just differentiating with respect to p, 3n squared pq plus n into 1 minus, the power term comes front, 6p plus 6p square. Now pq into 3n squared pq plus n into 1 minus 6p into 1 minus p. Just we are taking it as common. Then for 1 minus p, we are substituting it as q and taking n outside. Next step, npq into 1 plus, we are taking npq outside, so that it becomes 1 plus 3pq into n minus 2. Thank you. To be continued.